I'm Anil Kumar, and in these set of videos, we are trying to understand how to solve linear trigonometric equations. Now, for all our solutions, we will assume that the angle theta is between 0 to 2 pi. If not mentioned, we will take that as our default value. Now, to solve any trigonometric equation, at times we might use the graph, or we might use the calculator, or sometimes we may use special triangles to find exact solutions, right? So let's begin this one by using graphs. So in this video, we'll discuss about sine theta, cosine theta, and tan theta, right? So to begin with, let me share with you their graphs, and then we'll explore these one by one. And I'll sketch these graphs in the domain 0 to 2 pi, right? So, and for tan, I will draw it in the domain minus pi by 2 to pi by 2, okay? So I hope you understand why. Now, for sine and cosine functions, the graph is repeated after every 2 pi. So for sine theta, the graph is kind of like this, where it has zeros at 0, pi by 2 and 2 pi. For cosine theta, the graph is kind of like this. For tan theta, I'm just drawing one rough sketch, and this graph is, let me write down their domains. Here we have 0, pi, 2 pi. The values are maximum 1, minimum minus 1. That is for sine and cosine. However, for tangent function, I have not sketched domain 2 pi, but I have already sketched just between minus pi by 2 to pi by 2. Reason is that the period of tan theta is pi, and this is the function which is repeated, right? So the next will be kind of like this, right? So that is how it is repeated, right? Now repetition is after every pi. So the period for tan is pi. That is to say, this point here is at pi, right? So 0 to pi. Similarly, I could have drawn one on this side, but we'll just restrict ourselves to these two. Okay, so now we're talking about solving linear trigonometric equations. Let me begin with some very basic equations, right? So my first equation is sine theta equals to 0. You need to write solution here. Then we have sine theta equals to 1. You may write solution there. Then we'll take sine theta equals to minus 1. Now, can you tell me all the solutions for these three basic equations for theta within 0 to 2 pi? Now, from the graph, you can very easily see that sine theta is 0 at 0, pi, and 2 pi. So here the solution is 0, pi, and 2 pi. For 1, there is only one value, for sine theta being 1, and that value is at pi by 2. So this solution is pi by 2. For minus 1, this happens as minus 3 pi by 2, right? So that is minus 1. And there is only one solution, 3 pi by 2, in the domain 0 to 2 pi for minus 1 and plus 1, as you can very clearly see, right? Now, if I say that sine theta is some other value, not these. So let me take some other value. Let's say sine theta equals to, let us say it has to be between 1 and minus 1, right? So let's say 0.25. Now, what is the value of theta? To find this value of theta, we need to use calculator, and that too, we have to check radian mode, right? So we'll convert the calculator to radians and then find theta as sine inverse of 0.25. So we do shift sine inverse of 0.25 and write on our answer. 0.2526 is our answer. So we get one angle which is theta equals to 0.2526. Now that is the kind of answer you get. This is for sine theta equals to 0.25. In the domain of 0 to 2 pi, however, we should have two solutions, not just one. We are looking for a value 0.25. That is to say, if I sketch a line here at 0.25, it crosses at 2 points. One is at what we got, 0.2526. The other one should be pi minus 0.2526. You get the idea? So for other angles, we will get two solutions. So that is theta 1 and theta 2 for this will be equals to pi minus 0.2526. So we'll again take the calculator and do pi, which in our case is shift this, minus 0.2526 equals to 2.888, right? So we get this as equals to 2.8, we can say 89 if we round it to two decimal places. So we see for any other angle, we might get two solutions as we found in this particular case. But these cases we are going to explore further in our next video. Let us concentrate on basic three values for rest for the time being. Okay, so now let's consider cos. Now can you write down the solution for cos theta equals to 0, cos theta equals to 1, cos theta equals to minus 1. Well, for 0 we have two solutions, right? And these solutions are at pi by 2 and 3 pi by 2. So we have solutions at pi by 2 and 3 pi by 2, correct? These are our solutions. Cos is 1 at two places, at 1 and at 2 pi, right? At 2 pi. So cos theta is 1 for 0 and for 2 pi. As far as minus 1 is concerned, cos theta is minus 1 for pi. So here we have only one solution. Now let us look into tan. Tan theta equals to 0. Now as you know, tan theta is sine over cos. So if sine theta is 0, tan is also 0. So we could write that as our solution. That is one way of doing it. The other way is tan theta is 0 at 0, right? So we can write one solution as tan theta as 0. Next, we know that tan repeats after every pi, right? So we can add pi to this. If I add pi, I get pi. Again adding pi gives me 2 pi. So between 0 to 2 pi, I have these three solutions for tan theta equals to 0. You get the idea, right? Now let's look into the value as tan theta equals to 1, right? So if I want tan theta to be 1, then we can use the calculator, one part. We can use special triangles, other part. So tan theta is 1 for a special triangle, 45 degrees, right? So if I have 45 degrees or pi by 4, then tan theta is 1, right? So for 1, that is your special triangle. So tan theta is 1 for theta being pi by 4. Since the time period or tan theta repeats after every pi, if I add pi to this, I get the second value. Think like this. So these are the values where it is 1. Do you understand? So the first one is at pi by 4. The other one will be, we add pi to it. That means 5 pi by 4, right? So within the interval of 0 to 2 pi, there are two values for which tan theta is plus 1. How about tan theta being minus 1? So we say tan theta equals to minus 1. We know tan theta is minus 1 when you are in quadrant 2 or in quadrant 4. So we'll apply the cast rule. Okay, so we'll apply the cast rule. Cast rule is that all are positive in quadrant 1, sine is positive in quadrant 2, tan in 3, and cosine in 4. Minus means we are looking for quadrant 2 and in quadrant 4. So this is the kind of philosophy which we are going to use in coming videos, right? So we are looking for acute angle of pi by 4, but in quadrant 2 and quadrant 4. So that gives us angle of 3 pi by 4, and this is, so we have pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4, 5 pi by 4, 6 pi by 4, and 7 pi by 4. So we get two solutions. One is 3 pi by 4 and the other one is 7 pi by 4. Now all these solutions which I gave you here are in exact value, right? At times you can use calculator. If I use calculator for the last question, which is shift tan inverse, we have to write -1 to get the answer. So we get one of the answers, which is minus pi by 4. Do you get it? So at times you can also write this answer as minus pi by 4. You get the idea? But our domain is from 0 to 2 pi, and therefore we cannot write this answer as minus pi by 4 shown in the calculator. What I'm trying to say here is that even if you use the calculator, you may not get the right answers. Therefore, you have to follow the correct method. Find the acute angle and then the other principal angles. If the calculator is giving you minus pi by 4, you know the angle is like this. You have to see its equivalent angle going counterclockwise, the principal angle, which in this case will be 7 pi by 4, and report 7 pi by 4 as your answer. Now remember, tan has a period of pi and it is negative in 2 quadrants. So you should find pi by 4 in quadrant 2 also. Then you will get 3 pi by 4. Otherwise, using calculator, you will not get the answer for tan theta equals to -1. I think that is a nice place to stop this video, and then we'll begin the next one where we are going to use calculator and then check how to use calculator and find right answers. I hope that is going to help us. Thank you and all the best.